Okay, so this is the answer chaos of second quiz, online quiz. The first question is what term describes the rate of change in the translational speed of an object in the tangential direction as the object moves in a circular path? So an object is moving on a circular path, so like this. So then object is somewhere here. So then there will be something, the rate of change. When it says rate of change in speed, so you are going to talk about, it's in a kind of acceleration. It can be tangential acceleration, centripetal acceleration, but it's acceleration. Rate of change in speed or rate of change in velocity means it's a kind of acceleration. So your answer can be B or C. But it is the rate of change in translational speed of the object. So translational speed is, remember, so if an object is following a circular path, it can be a linear or non-linear path. So then we are talking about the translational speed. And another key, this translational speed of the object in the tangential direction. So it's going to be tangent to the circle. So first, it's going to be acceleration because rate of change in the speed means it's a kind of acceleration. But this acceleration will be tangential direction. It's going to be tangent to the circle. So then, acceleration, but this acceleration will be tangent to the circle, which is tangential acceleration. Answer is B. A car traveling at 20 meters per second rounds a curve. So this is V tangential speed, Vt, rounds a curve so that its centripetal acceleration is 5 meters per second squared. So AC is 5 meters per second. What is the radius of the curve? So equation for calculating this centripetal acceleration is tangential speed squared divided by R. So then if we are going to calculate R, which means R must be equal tangential speed squared divided by centripetal acceleration. Tangential speed is 5, square root of 5 divided by the AC, centripetal acceleration, tangential speed is 20. 20 squared divided by AC, which is 5. 20 squared is, let's do the calculation, 20 squared divided by 5, which is 80. So R is going to be 80 meters. So answer is C. When an object is moving in a circular path, the object's tangential velocity. It's talking about tangential velocity. So object is moving on a circular path. So velocity is a vector quantity. So its direction must be tangent. In tangent direction. Tangential means in the tangent direction. Remember, tangent must be perpendicular to radius. So velocity in tangent direction is called tangential velocity. So when an object is moving in a circular path, the object's tangential velocity is A, perpendicular to radius of the circle. This is the answer. Yeah, perpendicular to radius, because tangent is perpendicular to radius of the circle. It is perpendicular to the plane of the motion. Plane of the motion is, this is correct answer, but let's check other units. The plane of the motion here is the horizontal, but question says it must be vertical, so it must be into the page, but tangential velocity cannot be into the page. And C, constant. Velocity cannot be constant if an object is moving on a circular path because direction of the vector is continuously changes, so you cannot say that it's constant. It's directed towards the center of the circular path? No, it's not directed towards the center of it, it's along the tangent direction. Question number 4. An object has a tangential acceleration negative 10 meters per second square, which means this negative, it's slowing down. Negative means slowing down. So the angular speed will do which of the following? So then if it is slowing down, so the angular speed must decrease. So this is the answer. This is even one of the questions in your book. And question number 5. A microbe riding on the disk's rim. There is a disk So it's a disk. This is the center. Rim is here. So there's a microbe. This microbe has a tangential speed, which is equal to 1.88 meter per second. If the angular speed of the disk is 31.3, so this disk is spinning with an angular speed which is 31.3 radian per second. So what is the radius of the disk? Because we know that tangential speed is equal to r times angular speed. So then divide by omega to get to r, because questions are. Simplify omega. R is equal to V tangential speed divided by omega. Tangential speed is 1.88. Omega is 31.3. So let's do it. 1.88 divided by 31.3, which is equal to 0.06 meter. 0.06 meter, but to calculate, the answers are given in centimeter. You should multiply this by 100. 0.06 multiplied by 100, which is 6 centimeters. 6 centimeters is the answer. And there are 3 horses on a carousel. Horse A is 0.5 meter. Horse B is 1 meter. Horse C is 1.5 meter from the center of the carousel. Which horse has the greatest tangential speed? So remember, tangential speed equation is r times omega. Because carousel is a rigid object, so angular speed of every horse will be the same. So then tangential speed is proportional to radius of the circular path. Of course, the horse C is 1.5 meter away from the center, so that's why horse C must have the greatest tangential speed. And a rider 6.6 meter far from the center of the spinning ride at the carnival has the tangential acceleration. This time, tangential acceleration is given, so the rider is 6.6 meter from the center of the spinning ride at the carnival, which means this radius of the circular path is 6.6 meter. And right here it has a tangential acceleration at, which is equal to 3.3 meter per second squared. So calculate the angular acceleration alpha. We know that tangential acceleration is equal to r times angular acceleration. So then divide by r to get the alpha. Alpha is equal to a tangential divided by r. Tangential acceleration is 3.3, r is 6.6, so this division is 0.5 radian per second squared. So answer is D. And question number 8. Centripetal acceleration is defined as the rate of change of tangential speed in tangential direction. This is defining an acceleration, but in tangential direction, which is the answer of this question, tangential acceleration. It's not centripetal acceleration. The rate of change of angular speed when object is circular. So it's again defining an acceleration, but about angular speed. This change in the angular speed. Of course, it must be angular acceleration. It must be angular acceleration. This is not the answer. The rate of the variation, again, there's a change, but what? Variation of the direction of the velocity when object on a circular path. So that is the definition of the centripetal acceleration, because centripetal acceleration is because of the change in direction of the motion of an object on a circular path. How quickly its direction is changing, so then centripetal acceleration becomes greater. So this is the answer. And question number 9. A car is slowing down. This is one of the key. And as it makes sharp turn, here, this is slowing down. There's a slowing down in speed, decreasing in speed, which means there must be a tangential acceleration, because decreasing speed, increasing speed produce a tangential acceleration. But making a sharp turn, it's turning also, like this one. So if it is an object is turning on a circular path, so then which means there must be also centripetal acceleration. Centripetal acceleration. So that's why this object has a tangential acceleration and also a centripetal acceleration. However, if it has a tangential acceleration, Because we know that AT is equal to R times alpha. If there's tangential acceleration, and also, of course, this object must also have angular acceleration. And this object has the car experience centripetal acceleration, yes, because of the sharp turn. The car experience tangential acceleration, yes, because slowing down. The car experience an angular acceleration because if there's tangential acceleration, slowing down or speeding up of an object, this object also experience an angular acceleration. So the car experience all three accelerations in A, B, and C. Yes, this is the correct answer. And the last one. One of the equation below is correct. So these equations, one of them is correct. So then maybe you are not familiar with this type of them. Just cross product them. So cross product. Omega is equal to R times Vt. Are you familiar with this? No. The correct one is what? Vt is equal to R times omega. This is incorrect. So then, cross product again. At is equal to R times alpha. Tangential acceleration is equal to R times angular acceleration. So yeah, this is the correct answer because we know that tangential acceleration is reduced multiplied by angular acceleration. This is the correct answer. Look at this one, cross product. AC is equal to R times Vt squared. No, this is not correct. We know that AC is equal to Vt squared over R. This is not correct. Cross product. Omega squared is equal to R times AC. No, this is not correct. We know that AC is equal to R times omega squared. So this is the answer key of the second online quiz.